Hey guys, welcome to Unit C, Lesson 2 on log equations. Let's take a look at a log equation. First thing I'd like to do is identify the base in a log equation. So the base is always located here. Next, you need to understand that what the log is equal to is the exponent. So on that side of the equation is our exponent, and then this right here, I just say what b to the a equals. All right, so there's a couple different methods we can use to solve these log equations, method 1 and method 2. So I'm given the same log equation here. Method 1 is going to have you take the base, raise it to the exponent, and set that equal to whatever's inside. So I can convert this log equation to an exponential equation by taking 3 to the 4th and saying, well, that's going to equal x. So then obviously 3 to the 4th is 81, so x is equal to 81. That's method 1. Some teachers call it around the world, some teachers call it Ben. It's the same concept. Method 2 is we're going to identify what the base is, and then I want to exponentiate both sides of the equation by using that base. So since the base of this log equation is 3, I'm going to take both sides to the base of 3, if you will. Now, the reason why that's useful is because this base and log base 3 in that exponent cancel. So all I'm left with on the left side is x. And then on the right side, I just evaluate 3 to the 4th. Remember, that's a base to an exponent. And 3 to the 4th power we established is 81. So same result, couple different approaches. I'm probably going to use a little of both in this lesson. Let's take a look at our first example. Solve. We've got log base x of 2/3 equals negative 1/2. Now, this is really kind of a simple equation, but the fractions make it a little bit more confusing. So in this particular one, I'm going to use method 1. I'm going to identify my base is x. This negative 1/2, remember, is an exponent. And then this base to that exponent has got to equal this stuff right here. So if I convert that to an exponential, I'll take x, raise it to the 1/2, and set it equal to that. X to the negative 1/2 equals 2/3. So now it's an exponential equation, and I need to undo this exponent. So the way we undo an exponent is we take it to the reciprocal exponent. So now what I'm going to do is I'm going to take both sides to the negative 2, or negative 2 over 1. So x equals 2/3 to the negative 2. And remember, negative exponent takes the reciprocal of the base. That's going to be 3/2 squared. And now we just square the numerator and the denominator, and we get 9/4. Example 2, we can see we now have two logs. In order to use method 1 or method 2, we need to combine these to be a single log. I also notice I've got a 2 out in front here. Well, if you remember, a coefficient in front of a log can be brought inside as an exponent. So I'm going to do that first. Bring this inside as a squared, and then I don't have to worry about that anymore. Then if you recall, when you add two logs and you want to combine them to a single log, that addition becomes multiplication. So now this is going to become log base 3 of 4x times 5 squared is 25, and that equals 2. The base of the log is 3, so I'm going to use method 2 and exponentiate both sides. That base of 3 will cancel log base 3, so now I have 4x times 25, which is just 100x. 3 squared is 9, and we simply just have to divide by 100. X is going to be 9 over 100. Now we should also review, when you get your value for x, you need to check it into the original log equation to make sure that your domain is greater than 0. So what you get for x, you plug it into this expression right here, and that has to be greater than 0. So obviously x is a positive value. 4 times a positive is a positive, so this is going to stay positive. We see a similar setup in example 3 as we did in example 2, where we have multiple logs that we need to combine to a single log. So again, I notice here this is addition. That means that's going to become multiplication inside the log. So let me just rewrite that quickly as a single log. Log base 2 of 2x plus 1 times x minus 3 equals 2. And again here, I'm going to use method 2. I like to exponentiate both sides in this situation. I prefer to have my x's on the left. So the base is 2. I'm going to take both sides to the base of 2. And the reason that that's nice again is because it cancels with this log. While I'm at it, why don't we just multiply those two binomials together? That's going to give me 2x squared This gives me a negative 6x and a positive 1, so that's going to be negative 5x minus 3 equals 2 squared, that's 4. So I'll subtract 4 over, that's going to give me 2x squared minus 5x minus 7 equals 0. Now I'll factor this, it's got to be 2x and x. It's got to be 7 and 1, and I need them to subtract to a 5. So I'm just going to put the 7 here, the 1 there. Since 5 is negative, and I think it's going to look like this. So my two roots are going to be positive 7/2 and negative 1. Now, before you circle that and move on, remember what we discussed in the last example. These have to work in the domain of the given equation. So this right here, 2x plus 1, obviously this would not work. 2 times negative 1 is negative 2 plus 1, so I'm going to have to reject that result. They also both have to work here. Well, like I said, I've rejected this, but 7/2, if you think of it as 3.5, so 3.5 minus 3 is 0.5, so that would still create a positive value there. So this is my only answer. Okay, moving on. One more, actually two more, one with an E, but this one right here, again, let me combine these two. That's subtraction though, so now that's going to become division in the equation. So I've got log base 2 of x squared plus 4 over x minus 1 equals 3. The base of this log is 2. I'm going to exponentiate both sides. That cancels. Now we have x squared plus 4 over x minus 1 equals 2 cubed, which is 8. So now you can cross multiply, and that's going to give me x squared plus 4 equals, don't forget to distribute, 8x minus 8. Scroll a little bit more. I'm going to subtract these two terms over. So I'm going to subtract 8x from both sides. I'm going to add 8 to both sides, and that gives me a trinomial that I can factor, hopefully. So x and x, signs are the same, both negative. Multiply 12, combine to a negative 8. I think that's going to be a negative 6 and a negative 2. So I'll write it up here. My two roots are x equals 6 and x equals 2. And let's check them. So 6, yep, that works there, makes that positive. 6 minus 1 is 5, so that's going to work. 2, yep, that's going to keep that positive, and that's also going to keep that positive. So they both work. Here's our final example. Now, notice the directions here say exact value. All right, so that means you're not going to be throwing things into the calculator and writing a decimal equivalent. It's going to have a radical, could have pi. In this case, you see a natural log, so there's going to be an e in your final answer. The natural log is already isolated, so all we need to do is get rid of these first. So I'm going to subtract 7 from both sides. Then I'm going to divide by 3. So let's do that. I've got 3 natural log 2x plus 5. If I subtract 7 from both sides, that's going to give me 9. Now divide by 3, so I have natural log of 2x plus 5 equals 3. Now what we need to do is we need to remember that the base of a natural log is e. All right, so if I want to use method 1 here and exponentiate both sides, I'm going to use a base of e. And that will cancel with that natural log. So all I'm left with is that expression 2x plus 5. And because it says exact value, I'm not going to put e cubed into the calculator. I'm just going to leave it e cubed. So all we need to do now is get rid of this 5, subtract it from both sides, and then divide by 2. All right, so I have 2x equals e cubed minus 5. Now divide by 2. Just make sure you divide the whole expression by 2. So x equals e cubed minus 5, all divided by 2. And that is your exact answer. All right, so that concludes Unit C, Lesson 2. Please go ahead and do the 2 homeworks associated with that. Check your answers, and then there's a Delta Math assignment for Unit C, Lesson 2. Thanks, guys.